So right now I'm going to talk about the chain rule a little bit. I do chain rule a little bit differently than anyone else I've seen. So here's just a bunch of examples of working it the way I work it. These are the steps that we're given in class. So you can just pause, read those, look at them. I'll be applying them all right now. So here we have our first example. So what I want to do is I want to identify what my functions are. So this is my innermost function, is x squared, and then my outermost function is cosine, and I have nothing else. So I'll just put x squared here, and then my outside function is cosine of whatever is inside. So what I'll do is I'll differentiate each of them. The derivative of x squared is 2x. The derivative of cosine of something is negative sine of something. Then the way this works is you kind of take this, and these go this way. This one doesn't need anything, but this would appropriately be an x squared. That's what was in it in the first place. And then the answer to this problem will be the bottom with times. And you can make this a little bit prettier, like so, but negative 2x sine of x squared. And that is indeed the derivative of this original function. Here's another one. So I just have to identify what's my inside function. So once again here I've got two functions. I've got this one on the inside, and I've got this one on the outside. So my innermost function is x over x plus 1. I got my table here, and then my outside function is square root of blank. Now the issue here is that this one is not so easy to differentiate. So this one needs to be quotient ruled. So recall that quotient rule is low d high minus high d low over low low. So each of these is a 1, so that's x plus 1 times 1 minus x times 1 over x plus 1 squared. So this derivative will be x plus 1 minus x over x plus 1 squared, which is 1 over x plus 1 squared. So we did all that work, and all of that just comes back to here. And the derivative of square roots is, so I can think of this as something to the 1/2. So this will be 1/2 something to the negative 1/2. And then we fill in. So this goes here and here. So this was square root of x over x plus 1. And then we'll have an x over x plus 1 here. So my answer will be 1 over x plus 1 squared times 1/2 x over x plus 1 all to the negative 1/2. So you get just kind of take this bottom row of the column, multiply it all together, make it look pretty if you want to, but that'll be the answer. So there's two examples. Example 3. Ooh, this one should have had a closed parentheses here. But this one will have 3 functions. So my innermost function will be 2x plus 3. My second layer will be square root. And then outside of all that, I've got this cosine. Okay, so here I'll have 3 parts on my table. I've got 2x plus 3. I've got square root of something, and then I've got cosine of something, and those are my 3 functions. The derivative of 2x plus 3 is 2. The derivative of square root of something is, we just did this one, so it's 1/2 something to the negative 1/2, and the derivative of cosine is negative sine. Now we kind of do this cascade. This goes here, and here. And then the interesting thing is this goes here, square root of 2x plus 3, and here. And then once again, once I've finished all that, all I'm going to do is I'm just going to read across the bottom. So the answer here will be 2 times 1/2 times 2x plus 3 to the negative 1/2 times, be careful with this because this should be multiplied, sine of square root, close another parentheses. To make this look pretty, I can cancel those. So I've got 2x plus 3 to the negative 1/2. Pull that negative to the front, times sine of root 2x plus 3. Slap a parentheses on there because that looks weird. And that's the answer. fourth example. Oh, there I go, not closing parentheses again. Okay, so what's my innermost function? My innermost function is x cosine of x. Second would be square root. Third is sine. And fourth is tangent. Okay, so x cosine x, square root of blank, sine of blank, and tangent of blank. Okay, x cosine x, what has to be done here? This has to be product ruled. So you can have to product rule in the middle of chain rule. It is a frustrating fact of life. So x cosine x prime will be first times derivative of the second plus second times derivative of the first, like so. So this is x times negative sine x plus 1 times cosine x. So this will go here. We've got negative x sine x plus cosine x. Once again, square root will be this. Sine is cosine, and tangent is secant squared. This one is on a table of derivatives. And then I've actually done all the hard work here. This was not a straightforward problem, but now that I've kind of done my legwork, this goes here and here. And then these just kind of snowball. So this one will be root x cosine x. That's what goes here too. Root x cosine x. Then the thing that will go here is sine of square root of x cosine x and sine of square root of x cosine x. Written in tiny cramped handwriting because I didn't give myself enough space. That all looks nasty, but now I just have to put it all together. So the answer will be parentheses, negative x sine x plus cosine x. If you're following along at home, on paper, I apologize because I'm sliding over here because I'm out of space. Negative 1/2 cosine square root x cosine x, close parentheses, secant squared, sine square root x cosine x, close parentheses, close another parentheses, and I think that's good. So this monstrosity is the answer.